Another type of equilibrium reaction that happens in aqueous solution is the formation of complex ions. And complex ions happen with transition metals when we have either a neutral molecule or an anion that binds onto that transition metal. The way that we know that they are complex ions is because they still retain a charge. So even though they're complex, the overall structure or overall complex has a charge still in the solution. And so this is an example where we have silver that is becoming hydrated with water to form a complex. And those molecules or ions that form the complex or that bind are what we call ligands. So there's lots of different examples of ligands that can bind to transition metals. If a ligand is introduced that will bind stronger, it'll replace a current ligand. So as we saw that silver would bind with water, if we add ammonia to the into the solution, that is a stronger binding ligand, and so we'll form a complex with that ammonia. These equilibrium constants are still formed the same way that we've looked at all the previous equilibrium constants, which are products over reactants. And these now are called Kf for formation constant, so labeled Kf, and the Kf values tend to be very, very large. Formation constants can be very, very large. This means that the products are heavily favored. You'll notice that some of these constants are times 10 to the 25th times 10 to the 33rd, which means that those products are much more heavily favored than the reactants. We'll be looking at formation constants in the electrochemistry lab at the end of the semester, and we'll be dealing with copper ammonium complex that is formed and calculating the formation constant and also the concentration of copper that results from that. If we add a ligand to an ionic compound that can form a complex, it will shift the equilibrium towards the production of that complex because of our very, very large formation constant. Basically, what that means is we are essentially removing the silver from the product side, which forces the equilibrium of our solubility product towards the products, because we're removing silver so effectively by adding a ligand. So we'll essentially increase the solubility of our silver chloride by adding ammonia. So if we have a solid on the bottom of our beaker, simply by adding some ammonia to it will allow it to dissolve into solution because of that formation of our complex and that Kf value being so large.